All right, we are live. I don't like either one of these pens I'm using today. See if we can get a darker one like red. Hopefully this is a good one. So we're going to continue 3.4, which is on real zeros of the polynomial. Okay. So yesterday we talked about how to find your P's and your Q's and try to get some factoring. We talked about Descartes' rule of signs. We're going to continue to try to narrow this down a little bit. And so what we've got here is what we call the upper and lower bounds zero. Okay? All right, so what this says is let P be a polynomial function. Okay? And rule number one says if we divide P of x by x minus b, and we're saying that b has to be greater than 0 using synthetic division. And if the row containing the quotient has no negative entry, then B is an upper bound. Okay? So here's what that means. Is this dark enough, by the way? It's not? Let's see if I can try a different color. Got all light markers today. Okay, so let's say we're doing our synthetic division, and I pick a number, say 4. And let's say, for example, that when I do my P's and my Q's, I get plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 6, or something like that, okay? We'll just use those, okay? So I'm doing my synthetic division. I've got a bunch of whatever these numbers are. You know, these are whatever they are, okay? And what this says is, if the row containing the quotient, which will be this row here, this one's too light too. My markers suck today, I'm sorry. Let's try black. Let's say that I get a positive number and 0 and a positive and a positive and a positive, and maybe my remainder is positive as well. So I'll put R for remainder, okay? Okay, so what this is saying is, okay, because everything, I don't have any negatives here at all. Okay, all these are positive. Then that means 4 is an upper bound. There's no sense even trying to do 6 because 6 is not going to work. Okay? So that's one way that you can kind of narrow it down. Is you can say, oh, 6, there's no way 6 is going to work. Okay? Don't even worry about trying to find it. It's not going to work. Okay? So does that make sense what this means? Okay? Now, rule number 2, if we've got an upper bound, we also are going to have a lower bound. If we divide P of x by x minus a, where a is less than 0, so a is going to be negative, using synthetic division, And if the row containing the quotient and remainder has entries that are alternately non-positive and non-negative, then A is a lower bound. Okay? I know that's a little bit low, and I was going to say you can read it, but it's all backwards up there, isn't it? All right. So let's do the same sort of example here. This time I'm going to use a -4. Okay? So if I use a -4, let's say that I've got a positive, a 0, a negative, a positive, a negative, a positive remainder. Okay? So you can see here my quotient line here is alternating positive, negative, positive, negative, positive. Okay? So it's alternating. You can have some zeros in there if you need. Okay? Or if it happens out. But in any case, -4 is a lower bound. So therefore, there's no reason to try -6. Does that make sense? Okay. So let's do an example just to kind of prove this theorem, or to show this, this theorem. Okay. So let's say, I'm going to erase this. Let's say, show all real zeros are between -3 and 2. And here's my polynomial function. X to the 4th minus 3x squared plus 2x minus 5. Okay? Now, part of this is a little silly, because normally what we're going to do is we're going to find our P's and our Q's, right? Our P's and our Q's. What are my P's, Nathan, already?
I was here physically last time.
You were here physically?
Not much else.
Okay. So your P's are based on either that term or that term. Which one is it?
So 1 by the x to the 4.
So this is 1x to the 4. So is that my P's or my Q's? Nope.
Okay.
That's your Q. And your P's are? What are your factors of that? Say it again. 5 is a prime number, so the only factors of 5 are?
1 and 5.
Yeah, plus or minus 1, plus or minus 5. And so when you divide P by Q, all your possible zeros are basically that, right? Because that divided by 1 is just that. Okay? Now, the question says, we're trying to prove that all the zeros are between -3 and 2. Would there even be a reason for me to pick -3? No, it's not even going to work. Okay? But what I'm trying to do here is I'm just trying to illustrate that this theorem works. Sorry, this theorem here. We've got the upper and lower bounds theorem. Okay? So let's pick -3. Okay? And I'm going to pick on Kekana And I'm going to say, can you help me do some synthetic division with -3?
Yeah.
Okay.
One would be 1,
1,
0,
0,
-3,
-3,
2,
2,
-1.
-5. I'm impressed that you remembered the 0. Good job. Okay? All right, now do this down. So we're going to add down. We're going to get 1 and 0 is 1 times -3.
Is -3.
-3, 0 minus 3.
-3.
-3 times -3.
9.
9. -3 plus 9.
6.
6. 6 times -3.
18.
-18. 2 minus 18.
16.
-16 times -3 is going to be a positive 48. 48 minus 5, 43. Okay? So the idea here is clearly 3 didn't work, -3 didn't work. We knew it wasn't going to work. But you can see that I've got positive, negative, positive, negative, positive. Okay? Because they're alternating signs, what does that tell me? Then this is going to be my lower bound. Okay? So that means that -5 is clearly not going to work. No sense even trying it. Okay? All right, so we're going to do the same thing, but this time we're going to try 2. And so I'm going to erase all this. And then we're going to pick on Rory. Can you help me do some synthetic division on this? Okay? 1 and 0 is 1 times 2. 0 and 2. 2 times 2. 4 minus 3. 1 times 2. 2 times 2. 4. 4 times 2. 8 minus 5. 3. So I've got a remainder of 3. So no shocker that 2 didn't work. Didn't think it was going to work. But I've got plus, 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 plus. Therefore, what does that mean, Rory? 2 is an upper bound, so is positive 5 going to work? No way, no sense even checking it. Okay? So that's just an illustration of the upper and lower bounds theorem. Okay? You guys can ask that on my quiz tomorrow? Okay? All right. So, let's just do a good 5th degree polynomial because we're getting so smart. We can factor anything, right? All right, so let's go with, I'm going to factor p of x equals 2x to the 5th plus 5x to the 4th minus 8x cubed minus 14x squared plus 6x plus 9. Okay? So we want to factor this. So we're going to pick on Riley. What should I do first, Riley? What'd you say? Split it up? Split it up how? Can't hear you. You know? Okay, so we gotta have some ideas on factors that we can use, right? How do I find the factors I can use? I need to find my p's and my q's. Okay, what are my p's? So I can use plus or minus 3, plus or minus 1, and plus or minus 9, because that comes from that term here. Okay? What about my q's? Plus or minus 1, and plus or minus 2, that comes from my leading term there. Okay? So which one do you want to try first? What'd you say? 1. Okay, we're going to do synthetic division with a 1. And what are the numbers I put up here? 2, 5, -8, -14, 6, and 9. Okay, we're going to add down 2 and 0. 2 times 1, 2, 5 and 2, 7 times 1, -8 plus 7, -1 times 1, -14 minus 1, -15 times 1, -15, 6 minus 15, -9, -9 times 1, -9, and we get a nice fat 0 there. You're a good guesser, right? Okay, so this becomes a factor, and the factor is x minus 1, and then this becomes, if this is x to the 5th, this becomes x to the 4th plus 7 x cubed minus x squared minus 15x and 9. Okay? Now, my question is, I won't make you do this whole problem. We'll ask Daniel to help you out. Daniel, now we've got to factor this. Has anything changed from my P's and my Q's that I found earlier? No. Okay? Could positive 1 work again? It possibly could. So don't just say, "Oh, I used it, I'm not going to use it again." You might use it again, and I don't know. I haven't done this problem, so I don't know if it's going to work. So, what number would you like to try?
Let's go
3. Okay. 3, and so what do I write here?
2, 7,
Okay. 2 and 0. 2 times 3. 7 and 6. 13 times 3. 39 minus 1. 28, which is a big honking number. 3 times 8 is 24. 3 times 3 is 9, which is 11. 114 minus 15. 99 times 3 is a big honking number, and I'm going to have a remainder. Okay. Now, all these are positive. Right? Positive, 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 positive. Right? What does that tell me? What? It's an upper bound. So is 9 ever going to work? No. Negative 9 work, but positive 9 ain't going to work. And positive 3 doesn't work either. So now I've just eliminated a couple with one problem there, right? Okay. So 3 didn't work, but we did find out it was an upper bound. So I'm not going to try 9. How about, Joey, it must be your turn. What do you want to try?
well, let's try -3.
-3? We'll get to see if we can knock out that lower bound while we're at it. Eunice.
So I have a question. So instead of doing the division, can you just like plug it in and see if it equals 0?
You could do that, and then what happens if it equals 0?
Well,
Then you have to do this anyway.
Equals 0, then you do the division to find like.
Yeah. And if you want to do that, that's fine, and some students like to do that, but you're going to have to do this anyway if it's 0, so I just say do it. To me, it's just as fast. But yeah, that certainly would work. Okay? So Joey, what do you want to do now?
So it would be 2,
2 times -3,
-6,
-6, 7 minus 6,
1, -1,
positive 1.
or positive 1, yeah.
1 times -3,
It is -3,
-3 minus 1,
-4,
-4 times -3,
positive
12.
12,
12 minus 15,
-3
-3 times -3,
is 9.
9. You nailed it. So I got a nice 0 remainder there. Okay. So I'll bring my x minus 1 here. This factor is now what?
Negative, or positive,
So x plus 3. And I'm left with
2x or cubed
2x cubed
plus X squared.
X
Yeah,
squared.
X squared minus 4x.
4x
Minus 3.
minus 3. Okay? All right. So now, I always want to see if I can factor by grouping, but I don't think that's going to help me, is it? Okay? So Bailey, it must be your turn. What do we do now? Try a different number. Now, -3 could work again, possibly. So, but we know that's not, well, no, I guess we don't know that -9 won't work, do we? We don't know that. Okay? So what would you like to try next?
Let's do negative.
You're going to try -3 again? Okay, so we're going to try -3 again. And what do I write here?
2, -4, -3.
Okay, 2 and 0. 2 times -3, -6, 1 minus 6, -5, -5 times -3, 15 minus 4, 11 times -3, -33, and that's going to be -36. So that didn't work. But what do we know? The signs are alternating. So now we know that -9 isn't going to work. And we're done with -3. Right? Now what do we want to try? It must be whose turn? Zach, it must be your turn. So -3 didn't work.
-1.
-1. Okay. 2 and 0. 2 times -1. 1 minus 2. -1. -1 times -1. 1. -4 plus 1. -3 times -1, +3. I got my 0. Okay? So this becomes, what does this become?
X squared.
2x squared
Oh, 2x squared minus
x minus 3. Now, what does this become?
X minus.
I'm going to write it over here. X plus 1, right? And then I've got to put these here, x minus 1 and x plus 3. Okay, is this factorable? Let's pick on Tyler. Is that factorable? I think it is. What are your factors of 2x squared? 2x and x. Your factors of 3?
3 and 1.
3 and 1. So let's see here. If I got 3x and 2x, I can get a -x if I get my signs right. What are my signs?
Plus 3 and minus 1.
Plus 3 and minus 1. So plus 3 minus 1 is, or excuse me, plus 3 minus 2, yeah, the opposite. Minus 3 and plus. -3 plus 2 is -1, negative times positive is a negative, okay? So now I've got it here, x plus 1, x minus 1, and x plus 3, okay? Now, did we miss, oh, you know what, I think I erased one that I shouldn't have. Put that back there. Okay, so my zeros are x equals 3/2, -1, +1, -3. This has a multiplicity of 1. This has a multiplicity of, which one? 2, right? I got 2 of them. Multiplicity of 2. This has a multiplicity of 1. This has a multiplicity of 1. Now, it didn't ask you to do this, but you all know how to graph this now, right, Eunice?
Yeah.
How do you graph it?
Down to -1.
-1, +1,
negative 3,
-3,
and positive 3.
positive 1.5, right? Okay, what's your power function? Start back here. What is it? 5?
I don't know, I don't remember.
Forgot your power function? Holly remembers.
So y equals x to the fifth.
Y equals 2x to the 5th, but I'm fine with x to the 5th.
That's close.
Remember that now?
Yeah.
You're not gonna forget that on our test next week. Okay, so x to the 5th starts high or low? Sure? Sure? No? We gotta study better. Debbie knows.
Sorry, I just have a quick question. I'm just trying
Okay.
to think of something. Why does positive 1 have a multiplicity of 1 and negative 1 have a multiplicity of 2?
Okay, so if I set that equal to 0, what does x equal? X equals -1, and I've got 2 of them, right?
Oh, okay.
So that's why it's got a multiplicity of 2, okay? All right, now that you know that,
Okay.
by the way, are we on camera? You guys are terrible camera eyes, you know? So it starts high or low, Debbie?
Low.
Sure?
Yes.
Okay, good. All right, it starts low.
Mhm.
We're going to come to -3, and it
Process.
crosses. And then we're going to come to -1, and it bounces. And then we're going to come to +1, and it
Process.
crosses. And then we're going to come to 1.5, and it
Process.
crosses again. There you have it. Okay? Quiz tomorrow is on the rest of 3.4. See y'all tomorrow.